Thanks for the intro, Gleb. That was a good introduction. Tough to go third here. Great presentations ahead of me. So this is they're gonna be tough to top. Let me share my screen. So hi, I'm Gilbert. Like Gleb said, I'm a senior data scientist at Truebill, and I'll give you a little introduction to what Truebill is in a second. I'm going to talk to you today about using Apache Beam and include cloud Dataflow on Google's cloud to build streaming ML pipelines. I'm going to talk about our observations at Truebill about using these products and talk about how just easy it is. It's super easy. So first, a shameless plug. Truebill, it's the best.
Or you plug, not to cut you off on that one. Can you go full screen so we can see the? Awesome. Okay, yeah, please continue. It was awesome.
Sure.
Everyone download
Everyone download it. Managing money can be hard. Don't do it alone. Truebill empowers you to save more, spend less, see everything, and take back control of your financial life. It's a pretty strong statement. So go check it out now. But moving on to the meat of the talk. I always like to start with the business problem that we wanted to solve by using these two products I want to talk about today. You can't do anything without a motivating business example, or it's pointless to do anything without a motivating business example. So let's start there. So the business problem we had at Truebill is around ad measurement and Apple's new SKANetwork. What's SKANetwork or SKANetwork? That's Apple's new ad tracking transparency solution. You've definitely seen commercials about this. Apple's been touting it heavily. And it totally changed the way marketing and digital attribution is done. We're not going to get really deep into the technical details today, but I just want to highlight that it has changed everything in marketing. Let's talk about what has changed for Truebill in particular. When we used to do ad measurement before these changes Apple instituted, we had a pretty clean data sets we were able to use to measure how our ads were doing. We had some semi-deterministic ad attribution data. We knew exactly what ads users were seeing before they came onto our web app or onto our apps, and we could match that to exactly what users signed up for our premium product, exactly what users were doing in the app, what screens they were seeing in the app, what type of product interaction they were having. And we could use that data to measure ad effectiveness. What we would do is we'd have all that data in a database, and in batch, every 2 hours, we would run an ML model that produced an expectation of LTV. And just backing up for all those that don't have a lot of experience with ad measurement, what's LTV? LTV is user lifetime value. And if you marry that with the cost you pay to run ads, or aka acquire users, then if you have an LTV to CAC ratio greater than 1, you've got great unit economics, you're making money over some time period at least. If it's less than 1, that's not great. You're not going to have a business there, at least in the long run. So just a quick review on that. So this system was working for us, but again, we had very good fine-grained information into exactly which users ads were seeing before they showed up on our site. What changed? Apple removed this link between what ads users were seeing on what platforms and the users that we ultimately acquire and see in our app and in our web properties. Apple still provided a way for us to get aggregate attribution data from ad networks. So for example, we can still know exactly how many installs Facebook drove yesterday. We might know how many installs a particular ad campaign drove, but we can't link that to any single particular user on our side, on Truebill's side, and in the product, and that creates ad measurement problems, right? Because this user level LTV model we had built no longer works. Luckily, Apple provided some additional measurement methods and provided that through SKANetwork that we've tried to lean into. And we're not going to get super deep into that again. There's a really complicated flow diagram here to the right. If you want to go read more about that, like check out Apple's docs. But the key level points for us and what we need to know about this so that we can understand why we chose to go with Apache Beam and streaming ML pipelines is that we needed to design a system that delivered user-level expectations of LTV to the device very quickly so that we could use Apple's measurement schemes. This need for ASCP data back to the device as soon as the user installed or signed up for Truebill didn't work with our batch LTV pipeline. Like if you recall, we were only running our ML pipeline for LTV every 2 hours, and that just didn't work anymore. So we had two possible solutions. We could either design a ML system that's faster and can send LTV expectations to the device relatively quickly, which I'm going to call like our streaming LTV estimates to device solution, or we could put an LTV model on the device and have the device side code deal with all that. We chose ultimately to go the streaming side because it's a lot easier. We as a company just aren't prepared to do ML ops for the models on device. So that's why we chose that route. So what solution did we come up with? We decided to implement streaming ML pipelines on Apache Beam. And let's like walk through the architecture of what we designed, and then we can talk about why this was a good idea and works for us. So no longer is our source of data for our ML pipelines our feature set. Recall that in our batch pipeline, we had data about where ads came from or where users came from and what type of app interaction they were having. That data comes from Segment now, and Segment's providing us a near real-time data source for this data. It has because of the way we've implemented it, it provides very fine-grained information to what exactly users are doing on our app. And we pump that data directly to a pub subtopic. And then we have an engine that's designed using Apache Beam on top of Google's Dataflow product that reads in all those events and in near real time creates feature sets and creates ML predictions on top of those feature sets. It dumps those predictions and expectations to another pub subtopic, and we deliver those expectations to the user's device via background app push. And that way we can use Apple's measurement solution. So let's talk more about this middle piece, because that's what we're here for today. Why did we go with Apache Beam and Google Cloud Dataflow? Well, Dataflow is, or Google at least, is a heavy supporter of Beam these days. So one of the big reasons to use Beam is portability. It runs on Google's Dataflow product. It runs on Apache Spark. It runs on Flink. And because Google is supporting this project in a major way as of late, Dataflow just seems to have a lot of the best features for many of these runners. But portability is big for us because we can decide to move this to a different cloud on a different runner at any point in the future. It's important for us that Beam was open source. It works with us from a legal perspective. It's a unified framework, so if we ever want to create batch jobs that run on the same infrastructure, we're able to do that too. It's got multi-language support. It's got support for Python, Go, Java, so lots of options there. Most importantly, it's just a really nice abstraction. It's far less code than if you were to write this directly using Flink, the Flink SDK, Flink APIs or SDK. Same with Apache Spark, and that just leads to fewer programming errors. This is a data quality meetup, and I think this is the #1 point: is that less code, fewer programming errors, and that's why we like this for streaming pipelines. And it reduced the need for device side, back-end side development. For example, if we put a model behind like a microservice endpoint or something. So how easy is it? It's super easy, and this is a little bit of a simplification. But I mean, this is like 20 lines that is pretty much the meat of how we do streaming pipelines here at Truebill. So what's happening in here? We're reading in the events from PubSub that are ultimately coming from Segment. We're grouping those by user ID. Again, we still want to produce an expectation at the user level, so this is a key step. We are creating session timeout windows so that we know when we want to go send a expectation of LTV to the user device. We want that to time out after a certain amount of time. In this example, it's 5 minutes. So after no activity for 5 minutes, this pipeline will emit a expectation to the user device for use with this measurement solution. Finally, we map all of these individual events that we get from Segment to a set of features that we're going to use in our ML model. How easy is that? Again, this is a gross oversimplification, but this function you might use, it illustrates how to get like total event count, and we've defined many features in similar ways. Finally, we are going to use a model that we have trained elsewhere but are loading here in this pipeline, and that's very simple as well. Here's a good example. We're using XGBoost right now, XGBoost-based models. We've used lots of other stuff, but that works for us. So how well does it work? It works great. I mean, with a very minimal pipeline, we're like pumping through 200 plus events per second. We're pumping out 60 plus LTV predictions per second with less than like 20-30 second segment to end device latency. Like this really is working well for us. Could something else that's lower level worked better? Maybe, but we really like it. It's working for us, and the simplicity is a real value add. So with that, I'll send it back to Gleb.